All right. So today I wanted to talk to you about some of the latest examples of root RDataFrame and how this tool can help you scale your analysis on different deployments and also different use cases. I will be presenting from my side and also presenting the work of all the people that you see here reported on the slide. So let's start. First off, just to have a quick refresher, RDataFrame is the root entry point to modern analysis for energy physics, and it allows you to take your input data set and just process it in a declarative way, which follows also a lazy approach. You book all the information regarding your analysis up front, and then whenever you want to get your results, RDataFrame will take care of create a computation graph under the hood and optimize it as much as possible so that the analysis runs as fast as possible. And this includes also the possibility to seamlessly scale out to different computing clusters. Here on the slide, I just summarize some of the deployments that you could think about when using distributed RDataFrame. In particular, we have two main execution engines, either Dask or Spark. Definitely the former is the more popular one nowadays. And through them, we can offload computations to practically any kind of computing cluster, from bare bones to tightly managed clusters with Condor or CERN, for example. So thanks to this tool, we have tried and we wanted to try it out on different deployments, and in what follows in the next slides, I will show you different examples. So let's start from this first one. This was actually an effort that we made to test out distributed HEP computations, not only on a computing cluster, but on a computing cluster which uses a novel form of storage. So it's not a file system based storage, but it's an object store. In particular, it's called Intel DAOs. And in this case, we took this open data LHCb analysis, replicated the data set to make it large enough, so sort of roughly more than 1 terabyte of LHCb and tuples were used in this case. And then we tested out the tool using distributed RDataFrame, in fact, to see how it could scale. And we have here on the left the information coming from one single node, so scaling out this LHCb analysis up to the full capacity of a single node of the cluster, which was 16 cores. And you could see that we had a practically linear scaling all the way through. And when multiple nodes of this Intel DAOs cluster were used, we reached a plateau at some point. But the highest, so the peak throughput here is already quite high. These machines were quite powerful, and the novelty of the object store enabled us 37 gigabytes per second on 96 cores. That's roughly 400 megabytes per second, which was a good result at the time. And this first effort in that direction was published. I leave you the link to the journal paper down in the slide. And following on this pattern, I wanted to highlight another two examples of using distributed RDataFrame, this time on HPC centers. The one on the left is actually an HPC center that we have available at CERN. It uses Slurm for job scheduling under the hood. And in this case, we took another open data analysis, this time from CMS, ran it using either Spark or Dask to distribute the computation. So we also wanted to have sort of a comparison there on these particular machines that we have at CERN. And you can see that the scaling is quite good overall, up to the maximum amount of nodes. In this case, it was 64, which translates to 2048 cores. I'm not reporting here on the plot the peak throughput, but just as a I wrote the number here, so we could reach almost 100 gigabytes per second in the best case scenario. Also, in this case, the results of this effort were published, and there's another link to the journal here, to the journal paper. More recently, we tried the same analysis, so still this Daimyon CMS Open Data analysis, but on a different HPC center this time. It's the Eureka HPC center in Jülich. This was actually a collaboration that we had very recently with the CERN Open Lab this summer. Also, in this case, the HPC center uses Slurm for the scheduling. We only tested with Dask in this case. And here I report the total runtime of this application along the number of cores. So again, from 128 in this case, but the maximum number of cores is still 2000. So we wanted to sort of reproduce a similar testing environment as the one that you see on the left. In this particular case, the machines were even faster. The hardware was so we didn't see any bottlenecks, and what we tried out instead, then having a single dataset configuration, we tried having multiple dataset configurations to see if we could push the machines to their limit. In this case, you can see that the total runtime stays roughly the same. So on average is always the same, even though we multiply the dataset size by the same factor that the cores are multiplied by. So if you go from 128 to 256 is a factor 2. We started from 1 terabyte dataset size, we went to 2 terabytes, and you can see that this is replicated throughout the whole plot. Roughly the runtime stays the same, so that's kind of what we were going for. Also in this case, there was a recent presentation, and I'll leave you the link there. Yet another example. This time the analysis comes from CMS. This is actually a production analysis. In this case, the effort was translating the legacy implementation of the analysis, what is currently used in production, which employs Python for loops with the Nano AOD tools module and manual job submission to HT Condor, moving this to the new interface given by RDataFrame with the distributed layer on top to interactively submit the jobs to the Condor pools via Dask. In this case, the Condor pools were part of some tier 2 facilities of the WLCG. There's a publication link. In this case, if you read it through, I just wanted to highlight one of the conclusions that moving from the previous implementation to the distributed RDataFrame one gave an order of magnitude speed up almost. And in this case, if you take a look at especially the plots on the bottom row, you see that we are bottlenecked by the hardware. In this case, it was the network card. So we are still expecting further improvements that will probably be investigated in a follow-up effort. But that was already a good result. So we were quite happy with that. What happened more recently was that we demonstrated the scalability of our RDataFrame with the Analysis Grand Challenge benchmark. Here on the left side of the slide, I would just wanted to insert a link to the CHEP presentation that we had this year, where we demonstrated the scalability of this Analysis Grand Challenge benchmark, which I guess many people will be familiar with, using, as I said, our RDataFrame, but distributing it again on the CERN HPC cluster machines. In this plot, you can see that the scaling is pretty good overall. It's not perfectly linear. This is a log-log plot. So it's not a linear scaling, but already at the maximum amount of cores here, the total runtime for the execution on the full data set is less than a minute. So that's already quite low. We are investigating, trying to understand if we are hitting bottlenecks in the dataset size or there's something different there. But meanwhile, one other notable test that we wanted to drive is using Swan, and in particular the ability of Swan to connect to the CERN Condor pools to distribute the same analysis again with our RDataFrame. Since recently there's this possibility using the analysis service offered by Swan to connect to the CERN batch systems, and then just via Dask submitting batch jobs interactively, which is, in my opinion, is a tremendous new feature offered by this platform. So much so that I feel like it's enabling the rediscovery of some existing infrastructures and services that are already in production in a modern way. While testing things out for this presentation, and I left just a small screenshot here, I was feeling like the connection between these tools was so tight and so nice to use that it really felt like a modern approach to running this analysis, and it was nice to see. Still on the analysis grand challenge topic, we have a good collaboration between Root, RDataFrame, and the IRISEP people. We have Enrico and Andri, who over the summer have been working on developing further the analysis grand challenge. Of course, this benchmark itself is a moving target. It is versioned, so we already tagged the V1 version of the analysis grand challenge for our RDataFrame this summer, so it works with either locally or distributedly, single thread, multi-thread, or multi-node, and it has a bin by bin agreement with the reference implementation, so we had a solid baseline to start from. But then, as I said, Andri has done a great work in trying to move further the implementation and get it much closer to the new target, which is AGC V2, which includes also the ML inference task. You can see the links that I left in the slide for further details. And finally, I wanted to showcase a couple of usability improvement features that have happened over summer. One of them is the addition of a progress bar feature inside of our RDataFrame. This feature works in C++ or in Python mode. It works in single-threaded mode, or it works in multi-threaded mode. And support for the distributed mode is definitely coming soon. This is going to be available in the next root release, which is about to be released this week, most probably, or the next one. But you can already check it out in the tutorial just to see how it works. You will see that it's literally what I just wrote on the slide. So one extra line of code. And another very nice feature was the. Yep.
You should wrap up. You're already a third over the schedule.
Oh, sorry. Just last slide. Live visualization feature. You don't need to wait for your whole distributed computation to run before seeing the plots. There's a new tutorial, so you can call this function to just start plotting the partial histograms as soon as there's some task that has finished computations. And yeah, so that's the new feature. So coming to conclusions, RDataFrame, you can use it on one core or hundreds of machines. We have tested it on many deployments, and it's nice to see. It has been nice to see that all these efforts and results ended up in nice publications and collaborations with multiple groups. Thanks, and sorry for being late.